Okay, welcome back to the next video. If you've watched the series so far, last time we looked at something called work done, and this time we're just sort of moving on from that really to look at this topic called power. Now you will have heard the word power before, I'm sure. You may not know the official definition though. So this is the official definition for power. Power just means the rate of energy transfer. So in other words, it's how quickly energy is being transferred. Okay, so for example, if you had two electric motors, and they were both being used to lift up the same mass by the same distance, say, and one of them was able to lift up the mass a lot quicker, then that must be a more powerful motor, because it's transferred the same energy, but it's transferred it quicker. Right, so it's how quickly the energy is being transferred. So we can write this then as a formula. Again, not a particularly difficult formula. Power is just equal to the energy transferred divided by time taken. Now we can also write this another way. We can write this as a completely equivalent definition here, or formula, sorry. Power equals work done divided by time taken. Because we said last time that work done just means energy transferred by a force. And so if there's a force involved, the power will be the work done divided by time. Okay, we can have a look at our units as usual. Energy measured in joules, as we know hopefully, in both cases. Time measured in seconds. You do need to be careful with your units here. We'll look at some examples in a minute. Power. You may wonder what power is measured in. Well, power is measured in watts, or W. And just so you can sort of see how this all fits together, a power of 1 watt just means that 1 joule is being transferred per second. So when you hear about watts, you hear about power being measured in watts, it's telling you how much energy is being transferred per second. Now you can actually find often on the bottom of appliances or devices, you can find their power and sort of see how much energy is being transferred. So here's a calculator, and if we look on the bottom of the calculator, it's actually my brother's, but don't tell them I've got it. You can see there on this side, it says 0.0002 watts. So that means 0.0002 joules of energy is being transferred every second. Contrast to that, this is the base of my kettle. And on the back of there, on the label, you can see it says 2,520 to 3,000 watts. So that means 3,000 joules of energy are being transferred every second in a kettle, or you might see that written as 3 kilowatts. Okay, usual sort of thing then, we'll go through a few examples. So for the first example then, let's think about a cyclist. So true to form, I've got us a cyclist here, and our cyclist is going to be cycling along, and let's say, I'm going to move him up here just while I write, that this cyclist transfers 8,000 joules of energy in 40 seconds. Find his power. Okay, I've done quite an easy one to start off with. So usual setup, we're going to write our formula out first. So power equals energy divided by time. Energy is 8,000. Time is 40 and it's in seconds, so that is all good. And if you work that out, that will give me an answer of 200 watts. Okay, and that would be my answer, simple as that, if we're trying to work out the power. Okay, so that's a relatively straightforward one. Let's look at something a little bit more tricky then. So the cyclist has got home and wants to watch some TV. There's nothing good on TV, so they want to put on a DVD. They put on a DVD of the best program ever made. Just saying. Anyway, we want to find the energy transferred by a 250 watt TV during a 50-minute episode of Thunderbirds. Now, if we want to do this, then we've got to look a little bit more carefully. So I'm going to go back to my formula. I've got power equals energy over time. But this time we know the power, so it's the usual thing. Power is 250. I'm going to put in my 250 watts equals energy. That's what we're trying to find. Time. Now we've got to be a bit careful here because 50 minutes. We need our time to be in seconds, remember. So to get that into seconds, 50 times 60, okay, which is 3,000 seconds. Okay, so we know that our time actually is not going to be 50, it's going to be 3,000 because it's got to be in seconds. And so we're going to put that in down here, 3,000 seconds. Okay, I'm going to just push this up a little bit. Now, if we now want to work out the energy, think about it, if we times both sides by 3,000, our energy is then going to be 250 times 3,000, and I think that gives us an answer of 750,000 joules. Or you might want to write 750 kilojoules. Just remembering then 1,000 joules is 1 kilojoule. Okay, I might just take this opportunity to remind you of that. I'll put it down here. 1,000 joules we call 1 kilojoule. And another common one here, 1 million joules, would be called 1 megajoule. They're worth learning. We will do some more on those as time goes on. It's worth learning those. Same with watts. 1,000 watts would be 1 kilowatt, and so on. Okay, so that gives us then our answer for the amount of energy being transferred. Right, I put the third example then up there, you can see. Now this one's a little bit more complicated, and I wanted to use this as a chance to just point out to you that if you ever see a calculation in an exam and it's worth 5 marks, it's not just going to be a standard calculation. There is going to be a little bit more to it. And this is some of those harder questions that come up really to push you and try to distinguish those top grades. So if you're looking for the top grades, this is the sort of thing to be looking out for. Right, there are a few different things we've got to be really careful of here. So there's the question. The engine of a trike, here it is. The engine of a trike applies a force of 500 newtons and it moves 1 kilometre in 2 minutes. Find the power. So if you ever get a question like this, the first thing is just to look very carefully at what you know. So we know we've got a force there, we know we've got a time, we know we've got a distance. We're looking for the power, so I'm going to start off from there. We're looking for power and we know our formula for power. We've just done that. So power is energy transferred divided by time. However, I've realised that there's a force here, so maybe if we're looking at energy transferred by a force, I'm going to use this version of the formula. So power is work done divided by time. Now, you may well have noticed, and I hope you have, this 2 minutes. Well, we need that to be in seconds. So we're going to times that by 60. 2 times 60, 120 seconds. And that is something that we'd need to notice. But I'll tell you now, a very, very, very common mistake, if this was in an exam, would be that you would write, oh, work done, we're in an exam, panic, look in the question, 500 newtons, that must be the work done, we'll throw it into the formula and hope it works. Now that's what I call the sledgehammer approach. You're taking a number that blatantly doesn't fit and you're whacking it in there so that it fits. If you actually take the time to look at it, you know that that is a force. 500 newtons is a force. That's not work done. So we need to think a little bit more carefully. Can we find the work done? Now, it's quite hard to lay this out clearly, but let's just have a think about work done. Well, we had a formula from the last video for work done. Okay, work done is force times distance. And actually, we do have both of those things. So work done is force times distance. Force is 500 times the distance. Well, again, I hope you've noticed there 1 kilometre. So the distance is not 1, the distance is 1,000 because it's 1,000 metres. So 500 times 1,000, and that gives me 500,000 joules. So if we go back up here, power is work done divided by time. So that is 500,000 divided by 120 seconds. And if we actually do that calculation, I think that gives me 4,200 watts as my answer. So there were a few things in there to notice. You've got to notice you need to convert the 2 minutes into seconds. You've got to convert the 1 kilometre into metres. And you've got to see that actually you're not given the work done straight away. You have to work that out from other information you're given. Now do look out for that in exams and in the questions, any questions that you're doing. Because if you don't notice that and you just put 500 into here, you do run the risk of getting 0 marks for the question. That's 5 marks that you've lost, and that could be a whole grade different. That could push you up to the next grade. So always check that the number that you need is the number that you've got. And in this case, and in any case, the best way to check your units. Work done, you know, is measured in joules. This number here is measured in newtons, so that is not a work done. Okay, I hope that has been useful for you then, and now you feel confident doing questions to do with power. Starting in the next video, we're going to start to break this down and look at some individual types of energy. So we're going to start off next time by looking at gravitational potential energy and seeing how you can work out the gravitational potential energy. So I will see you on the next video. Keep safe, guys, and I will see you soon.